Let's turn these measurements into scientific notation. Part A. Zeros at the end of a number and to the right of a decimal place are significant. So all four of these digits are significant figures. That's going to make up our coefficient. Next, we need to move the decimal so the coefficient is a number greater than or equal to 1 and less than 10. So we need to move it 2 places to the left between the 7 and the 1. When we do that, we need to multiply it by 10 raised to the 2. This exponent of 2 corresponds to the number of times we move the decimal place to the left from the original number. Let's add our unit, and there's our answer to part A. Moving on to part B. Significant figure rules say leading zeros are never significant. So this measurement has 3 significant figures, the 2, the 3, and the 9. Those digits will make up our coefficient. Next, we need to move the decimal to make this number greater than or equal to 1 and less than 10. So let's move that decimal between the 2 and the 3. Moving the decimal place to the right means we need to multiply this by 10 to the negative 1. 10 raised to a negative power is the same as dividing by 10 that many times. Let's add our unit, and there's our answer to part B. Part C. All zeros between non-zeros are significant. So every digit in this measurement is significant. So all 5 of these digits make up our coefficient. This one doesn't have a decimal, but it's implied after the 3. We need to move that decimal 1, 2, 3, 4 places to the left in order to get our coefficient to be greater than or equal to 1 and less than 10. Another way you can say that is to make the coefficient have only one non-zero digit to the left of the decimal. Alright, so moving the decimal place 4 times to the left means we need to multiply this coefficient by 10 raised to the 4. This exponent corresponds to the number of times we had to move the decimal place from our original number. Moving the decimal place to the left means we increase the exponent. Moving it to the right means we decrease the exponent. Part D. All of these digits are non-zero digits, so they're all significant. We need to move the decimal 2 places to the left, and therefore we need to multiply this coefficient by 10 to the second power. Add the unit, and there's our answer to part D. Part E. Leading zeros are not significant. So we're going to write the sig figs, the 5, the 4, the 9, the 9. To make this coefficient greater than or equal to 1 and less than 10, we need to move the decimal between the 5 and the 4. That's 2 spots to the right from its original location. Moving the decimal to the right is the same thing by dividing by 10. So we need to multiply this coefficient by 10 raised to the negative 2. Let's add the unit, and there's the answer to E. Finally, F. This number has trailing zeros and to the right of a decimal point. This last zero is significant. Therefore, all the zeros in between that last zero and the leading one are all significant. Follow the reasoning. No one would ever write a 0 at the end of a number and to the right of a decimal if they didn't measure it. If this 0 in the tens place was never measured, there would be no reason to write it. So all of these digits make up our coefficient. Now where do we need to move the decimal to turn this coefficient to a number that's greater than or equal to 1 and less than 10? We have to move it between the 1 and the first 0. That means we had to move the decimal 1, 2, 3, 4 places to the left. So to compensate, we need to multiply this coefficient by 10 raised to the 4th power. Add the unit, and there's your answer to F.